Good morning to all. In this video, we are going to discuss one of the best simulator for 8085 microprocessor. Let us see how to download it and how to install this and how to do the simple program with the simulator. Let us go to google.com and type 8085 simulator, and while searching you will be getting lot of results. So out of which the third one is going to be the github.com. So this is going to be one of the simulator which we have used, which I have been using for the past few years. It is very nice, and it's very useful for the students to understand the concept of 8085, particularly the instruction set and programming can be understood very well. So you can see this web page, and it is developed by Jubin Mitra, and it's an open source license, GNU license, so that we can use it without any cost. We can download the software, and we have this is the software. You can download it, save the link as. Fine. So you can, I have already downloaded it. So I can again, I can download this, and we have got a documentation for 8085 and how to use this software also. So the source code is also available. Since it is an open source software, how the software is being developed is also given for us, so that you can see the source code of this particular software. So these are all the internal file. I think they have written the program in Java, I think. Fine. Those who are interested to develop this software further can make use of the open source available here. Those who are interested to use the software can directly go to the downloads, and you can see the 8085 compiler.jra. So you can simply click it, and you can see that simulator is opened like this. It looks like this. It's very simple. So in this simulator we have got an assembler, so in which we can write the program in our mnemonics. There is a operation code, opcode we have studied, and we can simply type. And also we have sample programs. Some of the sample programs are available here. You can simply load any one of the sample program and see that how a program can be written. So basically when you put a double slash here, then the whatever we type, it becomes the comments, and we can type this LXI H comma, the address is given there, and move A comma M, and you can see. So this is LXI A comma C050, and move A comma M, and complement the accumulator, store the content of accumulator to C052. That is the address location. And this is an place, that's hash org is the starting of the address you can give, and hash db means the data byte. So whatever the data byte you are giving, this will be started storing from the address mentioned in this line. So here we have mentioned as origination of C050, from which the data bytes which you have mentioned here with comma are stored in each memory location. That is a 85H is stored in C050, and C051 54H is stored. So this is the program. So once you have typed the program like this, you can simply assemble. Once there is an error, then this assembler will give error, and it will not get assembled. For example, I just remove this comma here, and the color is also changed. So when I press assemble, then it shows error. So something wrong with this instruction. So the comma is missing. So I can type the comma again. Now I assemble this again. So there is a error. What is that error? I think I have typed the comma. Okay, move a comma m. So normally it is a good practice to type the instruction in capital letter. Okay, so now it's okay. I think it was a full stop or an extra space was given, that's why it was not assembling. So I just removed a comma m completely and typed again. Now it is working. Normally the program starts at a 00 memory location, whereas if you are interested to start the program, you can type something like this. The first line of the program can be written like #org. You can mention whatever the address you wanted to start the program. For example, if I wanted to start the program at 4000, then I can simply type 4000x. Then I can assemble again. I see that the program is starting from 4000. So we typed only the mnemonics, that is opcode, and the hexadecimal code for this mnemonics are automatically generated, and each type of instruction is also mentioned here. It's a LXI H, the 16-bit address is considered as a 3-byte instruction. It has a 3 machine cycle. If you are interested to see the machine cycle completely, then you can simply click on the T states. It says 10 T states. Just click it here and you can see the complete machine cycle of this particular instruction. So those who are interested to know the machine cycle can go through the machine cycle, and it works very well. And now we have to give the starting address. So we have to start executing the program. The program can be executed all at once or step by step also. So the starting address of this program is 4000. So let me give 4000 here and then run all at a time. So which means that I have the program is being run and the results are stored. Where did we store the result? Actually the program is written as a 16-bit ones complement. No, ones complement of a 16-bit number. So we have run the program. Actually the content is 85 and 54 is the number that has to be complemented. So we can understand how it is working. So the results are stored in C053. So here register content can be visible, and if you click here, the memory content including the program what we have written and its hexadecimal code is also available here, which means the programs are written in the memory location and the programs are written in terms of the hexadecimal code. These mnemonics are for us to understand how the program should looks like and how the program is working. Actually the hexadecimal code is written here, and this is the code in which the microprocessor can get the information directly. The hexadecimal code means it's converted into binary. Only the binary code can be understood by the microprocessor, and its equivalent hexadecimal is given to us. So you can see the 4000 memory location 21 is stored, and 4001 the C050 is no. So LSB is stored first, that's a 50, and MSB comes next. So that is a C0. Similarly, this is a single byte instruction, move a, m, and this is 7E is a hexadecimal code. You can see 7E here. So the memory details can be seen here. The results are stored in C050 and it is 85, and C051 is 54. This is what the input data, not the result, because we have assembled again, so the results are gone. So we just type this one. I think we click this one Now we see the result, that is 7A and AB are the complement of 8554. So that can be verified using a calculator or manually also we can verify. So in the next video, let us see how the program can be executed by step-by-step execution. And while executing step-by-step, we can see the content of registers as well as the accumulator in each and every step of execution of the program. Let us see in the next video. Thanks for watching. To watch more videos like this, you can subscribe my channel